Welcome everyone to this week's OMR Architecture Meeting. This week we have one topic to discuss, and I'm going to lead the discussion on that. It is so I normally don't like to do this where we have a topic that isn't very well clearly defined and or have a proposal to go through. What I was thinking that we could do is I'd like to hear everybody's thoughts on the topic and perhaps to brainstorm some ideas on what it is that we need to do and perhaps even share some experiences from those that have tried to extend the compiler in certain ways. So let me just back out of this for a sec, and I will share something different, share my browser. So just a moment. Okay, so just have some talking points in this issue 5858. So wanted to talk today about defining an API for the compiler. There are some good reasons for needing to do this. One is, as the number of projects that are consuming OMR starts to grow, it's not a huge number right now, but certainly there are a few projects in the works. At some point, these projects are going to require that they're going to want to consume OMR from the wild. So there's going to be some expectation on stability of OMR that they're consuming going forward. So we started a release process with OMR in 2019, and we basically did a sort of a token release, but in late 2019. But we haven't really done anything with that since then. For that particular release, we had said that only a few components of OMR were ready to declare some stability on their API, and that was the port library and the garbage collector. But the JIT compiler and JIT builder were not part of that. And even though we are functionally stable, those components are functionally stable, the API isn't. And part of the reason for that is that it's particularly difficult to actually define what the API is to the compiler. So going forward, it would be very useful for us to have a notion of what that API looks like, how it is defined, how it is allowed to evolve, how we expect people and other projects to consume it, and going forward. So this is the whole point of this meeting is really to start that process of brainstorming ideas on what that compiler API could look like. And then we can hopefully start to put, once we have that, once we have an idea of where we want to go, we can start doing the right things in order to shape that API and get it to a point where others can consume it going forward. So like I said, I don't like to do these kinds of things, but unfortunately, I don't have enough information yet or enough insight yet to properly define something or even to propose something. So I am very interested in hearing what others have to say about it. So I've got a few points in this issue to hopefully guide the discussion that we can have. So first off, when we're talking about the compiler, we're actually talking about maybe two different things. The first is the actual, and I probably have these 2 points in the wrong order, but the first is the actual compiler itself. So it's a core collection of classes and functionality that language environments can consume in order to do compilation of something. And that compiler technology has got a fairly wide surface area of classes that someone would have to implement in order to use the compiler. And unfortunately, where things are at the moment, it isn't super well documented, and often the path that one goes on is to follow an existing implementation example to figure out what it is that needs to get done in order to implement a compiler that uh, with that means. Um, so that's one way of accessing the compiler. The other, it's sort of a reflection of the fact that this is a rather complicated interface, and many projects that would like to consume that would like a JIT don't want to go through that don't want to expose all that complexity to them. So we've developed a simplified interface to the compiler called JIT Builder, which allows the JIT to be constructed a lot more programmatically, and it provides a number of sort of ready-made components that you can put together in order to produce the kind of IL that makes sense for your language environment. So um, JIT Builder itself has got its own interface that is exposed to um, a consumer, and the underlying compiler interface isn't actually, you don't have to care about that. You don't have to worry about that. You only need to care about what JIT Builder is offering you. So there's two different levels of interface here that we're talking about. And one thing would be to perhaps consider, um, splitting these. Like, are these two separate conversations, or or is this, or are we talking about them together? In my mind, I've always had them together, but perhaps it does make more sense if the interfaces are going to be so different to have a JIT Builder discussion and also have a compiler discussion. So, um, so those are sort of the 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 ground rules here. Um, so jumping back down into the compiler, I said it's got a very wide surface area of classes. The conceptual integrity of all of those classes is generally sound, but the documentation of those classes may be lacking in certain areas, or could certainly be supplemented to make it easier to understand. The APIs provided by a variety of those classes are also lacking in many cases, with documentation and um, and examples for how they should be used. So one way of perhaps thinking about an API for the compiler is to think about all those core classes that are part of the API, and basically define them and say, this is the um, this is the level at which we are going to be defining our API. So public methods of node, public methods of compilation or code generator, or the optimizer, or the CFG, things like that. So that's potentially one way we could go with that. Um, the other way is to, or another way is to potentially say, what is the minimum set of compiler components that I need to consume in my language environment in order to consume a JIT, or in order to actually instantiate a JIT? And perhaps we build the API around that and say that everything else is is extra. Um, and then perhaps even the third option is to not even consider any of that, and then just go with the, how do you actually invoke the compiler? What's the minimum thing that you need to invoke the compiler? And what the, like, do we need an initialize method and a compile method? and some means for getting the compiled method back. Is that all the API is expected to be? So um, I'm gonna just stop there for a sec to see if anybody has any immediate opinions on that. I think actually it is a good place to stop and get other input on what they think of the compiler. Not necessarily think about JIT Builder at this point, but just the compiler itself. Are there any thoughts on what I just said or other different ideas on how we can proceed?
So off the top of my head, um, just thinking about the options you were mentioning, Darul, for how we can go about defining the API, I think the most straightforward approach for us is probably to um, look what you were saying about looking at what methods we have available currently in the classes and figuring out kind of what's the minimum set of things you need in order to build a compiler. I think that's probably the least effort for us simply because we're already starting from what we have. Um, I guess there is a risk in there in that we are creating an API based on an implementation. So it biases what the API is going to look like if we're not careful, right?
Mm-hmm.
Because it would be very easy to then create an API that reflects some of the assumptions that we make currently in the implementation of the compiler. And then later on, if we figure out that actually those assumptions are problematic, either they're not general enough or we need to change them, that is going to then in turn cause us to have to change the API. Um, so from that perspective, the way you would normally mitigate that is kind of think about it the other way and start off with an API that you want, and then implement that API in whatever thing you're going to build. But that's a lot harder to do when you already have a project that you're working with. Um, so those are my thoughts off the top of my head.
Were you thinking about um, applying that ideal API on the component level, or is this something that's a bit higher than that? So, um, um, I mean, it's true that the compiler is composed of many different individual components, various classes. I think it must be in the dozens of classes that need to get implemented or may need to get implemented. Were you thinking about the general API applying to each, or somehow um, aggregating them into higher level concepts instead?
Well, so I'm going to say all of the above in that that's kind of you're getting at the problem with the approach of trying to implement an API on top of an existing implementation. Um, it it's kind of something that, well, you would have to do it incrementally somehow, but without getting into how you would actually do it, um, my thinking is it's something that we would essentially have to apply in a way at all levels. So we would start off with applying it just with the different whatever high level components of the compiler we want for things like initializing the compiler, shutting down, um, starting a compilation, getting back the compiled method, and then applying the same idea one level down, looking at each of the classes we have, figuring out how do you actually build IL, right? All of that, anything that the user has to interact with will require this kind of um, exercise. So if potentially this could go all the way down even to the internals of the compiler, simply to make it consistent with everything so that we have one story for what our API looks like and how it works. Um, I don't think that's necessarily feasible, but in theory, that's how it would work.
Yeah, I mean, that sounds um, that sounds like a good plan. I think the one of the challenges that we have, and I think you've already kind of addressed this, is that we don't really have any kind of API at the moment. Um, so like there's no top to start going down from. Um, I think we would have to define those layers. Um, like what is the invocation? What is the initialization interface? What is the invocation interface? And then work our way down from that. So it's perhaps defining what some of those different levels are to begin with to start to form an API around.
Well, so yes, the risk there is that you're right, we don't really have an API, but we do have an implementation. So the problem that we're going to run into is when we find that the API we want disagrees with the implementation we have. So if initially, if you what you would call um, the top interface, we can start to define that and then kind of recursively work our way down. Um, and what we would find is that we start getting closer and closer to the implementation of the compiler, and that's when we start to discover um, inconsistencies between the thing we have and the interface we want. Um, there are strategies for working around that by basically adding more interfaces between things, with things like the facade pattern so that you hide um, the pieces you don't want to show. Um, but yes, we would be creating a new API and retrofitting it on top of our existing implementation.
Does anyone know of a compiler API that can evolve, that is general enough that it evolves with the implementation? I'm pretty sure the quintessential examples, LLVM and GCC, are probably not in that category, right? Like I know LLVM changes its API for various things at times,
Um, I
certainly in the details anyway,
yeah, you're right. Um,
from major release to major release anyway.
I think that the
Or
it,
is that possible? We have like certain options kind of provide or expose to the end user, and user can easily understand the options and combine or compose the those options to get the expected output.
yeah. So my view on this is the API and the implementation are two separate things. So we we want an API that the whole point of having an API is that when you're programming against it, you're programming against an interface, not an implementation. So any dependencies you create with the project should be expressed through that API, and you shouldn't be depending on details of how things are implemented. So I think LLVM does achieve this to some extent. It's true that they do change their API fairly regularly, um, but I think that at least some of those API changes are independent of um, the details of how things are working in the background.
Well, I mean, it just depends on what level you look at it, right? I mean, we've made lots of changes to implementations of classes inside the compiler that haven't required manifesting new public API to those classes. I guess what we're talking about is a
Yeah.
more global application of that
Yes.
reasoning. And I guess so if I'll ask kind of an existential question. So is it or maybe philosophical question, but like is a is a well-defined public API that has to change on every major release, is it really that much more valuable than an API that has some implementation dependencies and changes when certain aspects of the implementation change? Like, aren't those kind of the same thing? Like, to a degree. Like,
Yes, you're right. My response to that would be we should try to keep the API stable.
yes, I agree. Whatever the API is.
Yeah, whatever the API is, we want it to be stable. But we want it designed in such a way that we can change the implementation without changing the API. But there's also I do want to also acknowledge the fact that just because we can keep the API stable doesn't mean we will.
Right.
Right? So a project could choose to change its API because it decides that
Yep.
Whatever API it used to have is very error prone for its users, so they decide to deprecate it and replace it with a new API, right?
Right. But practically speaking, to the consumers, that's the same as this thing changed because you changed the implementation. Like, yes, the public API changed, but it's kind of the same thing. Like, it's an impact to your consumers who are going to have to figure out how to accommodate the changes that have been made to the public API that you've defined.
Yeah. So I guess then the point is you want to limit those kinds of changes to be nice to the user. So if you don't have if your API is very tied to your implementation, right, then any sort of change you make to how things work internally is going to require public API changes, and things are going to be disturbed all the time. Ideally, what I'm saying is we want to limit that. So by separating the implementation from the
Sure. I
API.
understand. I mean, I understand the principle and agree with the basic direction. I mean, who's going to argue against it, right? Really, you're trying to make a better world for your consumers. That's basically the nub of it, right? So that we have the flexibility to change the implementation, and yet the API is more or less stable. So our consumers, all they get is, the hopefully improvements made in the implementation characteristics without having to adjust their code to deal with changes in the API as much as possible. So, I mean, that seems like a valuable goal to me for almost any project with public API. I guess I'm a little worried that if we tried to do this at too fine-grained a level, we're gonna get into trouble. So, and I guess the other, well, maybe before I go there, so we also have a very intense current consumer who's used to having all of the implementation level hooks that it's using right now, right? So OpenJ9 obviously has a very tight integration with, well, I mean, it's a separate project still, but it's the most broad user of the current publicly exposed methods and data structures that are inside the OMR compiler, right? I hesitate to call that an API, even though it is kind of at some level the API of the compiler. But we have to understand how we would get to a new API without damaging the existing kind of dependency that OpenJ9 has on the existing public interfaces, which is going to be a challenge. I have to be candid about that. So I guess and sort of putting that in the perspective of I'm not really aware of a compiler project that has successfully created a very like I know LLVM has done it in a large number of cases, but you know, I also know that their public API changes on a regular basis too, and that does impact users in various places. So, you know, there's value to it, but there's going to be a knee of the curve, and I kind of wonder if maybe what we should start with is something more like what Daryl's got written here, like sort of defining, like we lack a lot of sort of core documentation on what are the main classes and what are their purposes and what are the boundaries between them, what are their areas of responsibility, what are their life cycles, that sort of information, which is all kind of collectively maintained by the group of people who work on this stuff, as well as, you know, the pieces that are obviously encoded in the code itself. And I guess the last comment I'll make, sorry, because I know I've been talking for a long time, is so one way of looking at this is that JIT Builder is that API, right? Because it implements basically the minimum amount of stuff that you need to do in order to create like instantiate the OMR compiler to be able to meaningfully do stuff. It provides a set of APIs, which I tried to design, and at least I know it's changed as well, but tried to design in a way that could be more sort of stable from release to release, trying not to make them implementation specific type exposures. It specifically avoided exposing the compiler API for partially that purpose. And you know, that's sort of the minimum that you would need in order to use the compiler, right? You need a way to be able to put stuff in. You need to be able to, you know, initialize the compiler. You need to be able to compile stuff. You need to be able to shut it down when you're done, and you need a way to tell it what code to compile. And that's basically what JIT Builder is. And if you wanted to do more elaborate things, then yeah, you're into a different part of the API, obviously the API of the compiler component itself, but there's nothing stopping you from doing that as either extension of the JIT Builder project, or by making your own copy of the JIT Builder project and hacking to your heart's delight. So that could also be considered, I guess, a practical way forward here, is sort of start with JIT Builder and then expand out the various bits that are underneath or alongside that are not just about injecting IL into the compiler and getting native code out, and see where that can go.
Yeah, I mean, certainly looking at JIT Builder, you know, the API seems to be it seems to be more, and with all credit to you, fairly well thought out, and you know, at least with an attempt of architecting something that would be of architecting an API. So, and it's, I mean, at the moment it doesn't have a lot of consumers, so there isn't, you know, there's less opinions on how that API needs to evolve to match some existing implementation of something. So I think you're right that could be a starting point. However,
I agree with all of that, except for the fact that I'm totally killing it with JIT Builder 2. But anyway, let's not drag that into this conversation. So I'll just say it and keep going.
Killing it in a good way, or
well, I mean, it's becoming more of a compiler, which means it's getting more of the same kinds of challenges that we've got with the compiler component itself, right? There's just more surface area to have to worry about.
Okay, so because there is that opinionated consumer of the OMR compiler at the moment, while you were talking, I was actually thinking if there was some way that we would inject another API somewhere between a JIT Builder and between the collection of classes that we call an API for the compiler at the moment, so that the opinionated consumer can, at least for now, you know, tinker with the internals, whereas what we try to expose at the compiler level is a bit of a higher level API that hopefully has more stability and maybe even more language agnostic features in it. But I'm not sure if I want to propose adding a third API in this list of 2.
Well, I mean, I think there's an argument that that could be considered an extension of the JIT Builder API, but it might be in a different kind of flavor than the existing JIT Builder API just because of the focus on IL generation in the current JIT Builder API.
Mm-hmm.
So that could just be the seed that we start with, because that's kind of the part that we fleshed out as the part at the beginning. And, you know, there are certainly other there are other requirements from JIT Builder consumers that I think would benefit expanding certain other aspects of the JIT Builder API, like the initialization sequence. How do you, like right now, that's actually one of the places that does expose a little bit. It's an optional part, but you can specify TR options as part of your initialization call, right? That has nothing to do with JIT Builder. It's all purely internal names of options that only the OMR compiler knows about. And you don't have to use it, but you can use it. But that degree of like figuring out how you start exposing more details of, say, the initialization process or the configuration process is certainly an area that I think people would like to see.
Right.
It's certainly some of the areas that I had to do a bit more work on with JIT Builder, the JIT Builder 2 prototype that I'm still working on is you know, I did have to expand on some of those areas.
Okay. Okay, so in your mind at the moment, what do you consider to be the sort of publicly facing part of JIT Builder? Is it just the yes, there's that invocation API.
And it's the client API.
And
it's the client API,
okay.
basically. It's the thing that gets generated by the API generator code that Leonardo wrote. Which is basically what was meant to be the original public API of the JIT Builder classes that were.
Okay. From the okay, and then going down a level to the compiler. I mean, I think that it would, there's sort of we can go around in circles on this, because you know it would be nice to actually have the core components of the compiler, the building blocks of the compiler, if you will, you know, clearly defined and documented, and as language agnostic as possible. I think that if we had something like that, that would form the basis of maybe taking the next step with the compiler, and perhaps putting, like, defining a higher level API on that. But I think just like for all these different components that we have, like, what are the components that we think are required for a consumer to consume, and how do they work? What do the APIs look like, and what are they supposed to do, and how do they interact with other things?
I would argue you'll have trouble. Sorry, finish your thought.
No, go ahead.
I was just going to say, I think we'll have trouble defining a public API before we've defined what the sort of boundaries are of those major components. I mean, I think that's kind of a fundamental aspect of being able to define the API is you have to first define the elements of that API.
Right. Right.
Not to
And
Okay.
probably the most important ones are the ones that have to be implemented by JIT Builder, like the JIT Builder project, the extension, right? Like all the code that needs to get written, that's OMR Compiler code that creates all the lifecycle stuff around the JIT Builder API, right? Like having to extend resolve method and having to call into the create the IL generator method details and all that kind of gorp, right?
I think as
Defining the optimizer, defining the JIT Builder optimizer and what passes it's going to run, that sort of stuff.
yeah, I think as a not to jump us ahead to the next thing, but I think as part of this conversation, the in some cases, in some sense, the extensible classes, the extent to which they are extensible and which classes are extensible, is it ends up currently providing something of a kind of a kind of API to a project that's trying to sort of consume the existing OMR project. And so to the extent that those can be sort of more clearly defined and documented and standardized, I think that feels like it would be a useful beginning stage of having an API.
Yeah, I agree with that too. Actually, you made me think of something as you were talking, that they're kind of different parts to the API that different sort of use scenarios, I'll say use loosely, compiler implementers, people who would implement changes to a compiler, I guess, or add things to a compiler would do, right? Like there's some people are trying to build a different front end. Basically, they're trying to incorporate the compiler into another runtime system and use it to generate code. Some people are trying to implement new optimizations and they want to be able to test them in the context of the compiler lifecycle, an existing compiler lifecycle or runtime. Some people are trying to add a code generator and understand what they need to do in order to add a code generator for a platform that isn't currently supported. Those kinds of, like, there's kind of different classes, I guess, of things. I mean, you could bundle it all up into one single API, but maybe there's value in thinking about those kinds of, I guess, user stories, for lack of a better word, phrase. Maybe there's value in looking at it from that aspect as well. Like that also allows you to kind of compartmentalize parts, like think about a smaller part of the problem at a time, maybe.
Yeah, I think that makes sense too.
Like adding an optimization, for example, doesn't have to touch all of that lifecycle initialization, code generator, extending instruction and all of that kind of gorp. Whereas if you're doing a code generator, obviously you need to understand very well how instruction works, how the machine works, how all of the register dependency stuff works, and all of the other kind of, lower level bits and bobs, registers in themselves, linkages.
Those are good points. On the topic of extensible classes, so I did want to mention that. So we've introduced the notion of extensible classes into the OMR compiler for a variety of reasons. I will admit that we often hear that there's potentially some confusion around them. It's a very odd-looking pattern, that kind of thing. But at the end, it serves the needs that we have in the project around allowing other projects to extend without introducing a lot of their own specialized extensions in the public code or the common code. There was a research project that tried to study the use of extensible classes, and they looked at all the requirements of the project, all the constraints, things like that, and the conclusion was there was no recommendation of anything actually better that would solve. It's not saying that extensible classes are the best, but there wasn't any other clear alternative that would address the needs that we have. So the reason I'm saying this, though, is that going forward, it seems like extensible classes is the main means that we're going to have to provide extensions to many of these classes, core classes that will be part of the sort of public API. So things like node or compilation or the instruction class, things like that. They're going to use this notion of extensible classes. And certainly if anybody has alternative thoughts on extensible classes, soon would be the right time to raise that. But if we're going to go forward with extensible classes, I think that there are some ways that we can make some changes to them to perhaps make them more like an API or more API ready. Like one of the challenges that we have right now is enforcing what it is that we want, like controlling what it is you want to make extensible or not. So there isn't really a way that we have to say that, this particular API, this particular method, this particular function, I'm going to allow you to extend in your project. There isn't this sort of way of marking it public. Basically, everything is public. So I would think we would almost need to introduce some kind of, and I'm going to say, just sort of as a suggestion, not necessarily the right thing to do, but if we had some kind of an attribute system where a C++ attribute system where you could define, or the OMR project could define, these are the things that I want to expose as possible extension points, and these are things that are not, then I think that would go it would be helpful to control the API as we go forward, I think, because right now everything is public. So, and if we did introduce those kinds of attributes, we could actually have like broaden the tooling that we use, the linting technology that we use to check that the APIs are being used properly, or these extension points are being used properly. And the technology that we have, the Clang tooling that we developed, we can make it easier for downstream consuming projects to use in their own projects to check that these extensible classes are being used in a way that the OMR project wants you to be using them. So that's really the point that I wanted to raise about extensible classes. I think it seems to be the strategic technology that we're using and we're going to be using, but I think if that's going to be the case, then we have to harden it a bit with potentially some compiler extensions to those APIs to make things a bit easier to do. And we could also do things like we can set aside certain functions to be known to be not extensible, and therefore they won't require the self methods, right? So simple getters and setters for things like the compilation object or the code generator object or other things like that, or memory that aren't very unlikely to be extended. We can basically say those get a pass from requiring self methods, and it'll make the code a little bit more readable as well for the consumer of the API. So, any thoughts from anyone on extensible classes or anything that I just said there?
I agree with it, but it sounds to me like kind of mechanics. That's what you would use to help enforce the API that you're trying to define. right?
Yes.
Oh, one more thought. Like currently, seems like the especially for the new user to follow and understand the extensible class style, the pattern, somewhat especially for me at the beginning, somewhat confusing because there's lots of similar files or exactly the same file names and but have the different extensible capabilities at different levels. That's somewhat like there's a some tool can help the example the new user they want to make a extension for a particular function or class. Is there a kind of helper or automatically tools to help the user to kind of easily extend the class or the methods? Is that something like possible or?
Yeah, I think it is possible, and in fact, prior to open sourcing this code, there was some development on tools to make that easier to do. I don't think that ever really went anywhere, but the effort that was put into that though suggested that it was possible to do. So I think you know, you're maybe raising a good point about some of this as well, and that just in terms of to make things more consumable and to make things easier to extend, perhaps there is some tooling that could be developed to assist consuming projects with making their own customized extensions. Perhaps by something that just goes and creates a skeleton class for you that does all the right, that inserts the code in the right places and includes the right files and puts the right defines in the correct places that we would expect. So yeah, I think that's a good suggestion, James.
Yeah, and another confusing part for me is like based on my understanding is usually the extensible class is only allow a single chain inheritance hierarchy. But when I reading the source code in the optimizer, like looks like the optimizer itself is a top level of the base class of all other specific optimizers. It's for me it's somewhat confused. Like so we can still extend the inherited class from the optimizer and deal with all kinds of various scenarios. It's that somewhat I'm not clear yet.
I mean, yeah, I mean, the extensible classes is a solution for like static polymorphism, but we're not precluding the use of, at the moment, we don't preclude the use of dynamic polymorphism in the compiler if that's the most sensible thing to do. So I think what you see in the optimizer hierarchy is a mixture of both. You may have a base class that's composed for static polymorphism, and then you've got a dynamically polymorphic hierarchy built underneath it. Same thing with the instruction class, it's like that as well. So that I think should be allowed if you're asking about, multiple inheritance with extensible classes within the extensible class, like the components of the extensible class. I think that's going to be a little bit difficult to implement. I know we did give that some thought at one point, but we couldn't really get that to work in a practical way. So, but certainly all the feedback that you have and others have had on consuming this technology is useful, and whatever the pain points you have, we can certainly try to address those as a community.
Yep, great.
Okay, so right, so extensible classes, I think, are going to be are certainly part of the compiler API, and they're likely here to stay for the foreseeable future. However, there are other parts of the compiler that aren't at the moment extensible, or they're not extensible classes, yet they are things that downstream projects can consume as well. So I guess I just wanted to mention that when we're talking about things that could be publicly consumed from the compiler, they're not all going to be extensible classes, or maybe they should be. I don't. Maybe that's an open question whether or not anything that's consumable from the compiler should be extensible. I my feeling is no. I think that that's just adding, a lot more complexity than perhaps the compiler needs. But if others have thoughts on that, please share any opinions.
Yeah, great. Thank you.
One thought on that maybe is just that the having anything that is exposed kind of as part of the API as an extensible class, just despite whatever complexity there is to sort of understanding extensible classes at the outset, maybe for a new consumer of the project, once a project is doing that and consuming kind of integrating with the project by using extensible classes as its kind of as its sort of entry point to as its interface to OMR, having all of those kind of interface points be extensible may actually be something of a benefit because it makes the interface consistent. I don't know. That's something that to consider maybe.
Yeah, that's true. There is a certain, and it also, yeah, I mean, a downstream project can feel comfortable in the fact that any sort of public API, any of the APIs can be extended and customized the way that they want. I guess the thing that like there is a certain overhead with extensible classes, and I don't mean a performance overhead. I mean just the implementation overhead with these extensible classes. In terms of the number of header files that you may need and the way that they get connected and that kind of thing. That it they're that kind of thing may not be particularly palatable for a lot of things. Like we may just have an explosion in terms of the number of files, for example, which may not be a bad thing. I don't know. Maybe I don't want to form an opinion on that, but yet. But that's a good point, Kevin. That's
Sure. Yeah, and what you say is also makes sense.
okay. Okay, I wanted to move into another aspect of the API, and that being the compiler IL itself. So these are this is the tree the opcodes for the tree-based IL representation. And when we had open sourced the compiler, we had gone and we were actually starting from a very large set of opcodes from the original Java compiler where it was based from, and from that we carved off a set of a few hundred opcodes that we thought were useful for across different language environments, and so that's sort of where it is right now. But perhaps that set is a bit larger than it actually needs. But I think that as part of the API, I think we need to actually have a better idea, a better definition on the semantics of all the different components of the IL. So what exactly is the operation of each of the opcodes in that what is what are the expected inputs, what is the expected output, how can what is the role of a language environment in the interpretation of that? Are there means of changing the semantics, or are the semantics exactly the same for every IL? We had a discussion on this maybe a couple of years ago when we were talking about the floating point operations, and how different language environments, depending upon perhaps the floating point environment in place at that for that environment, for that language environment, may be different, right? So somebody could be following strict IEEE 854. Another environment could be following most of that, but they make restrictions on usage of nans and things like that. So they may have different interpretations of what result you would get from running certain opcodes. So do we allow that flexibility in the IL? So I think that at the very least, defining some minimal set of semantics for the IL is important, and what it means for the different data types and that kind of thing is important to do. But I think that the IL has to be part of whatever API we define. Any opinions on that or thoughts? Okay. All right, and then perhaps looking at it, yet another aspect of the API within the compiler itself. There's the notion, there's the idea that you've got a language environment consuming the compiler, and we are potentially going to be defining an API for that consumption. But there's also a means for the compiler to ask the language environment for more information about certain things. And the way that that's been traditionally implemented with this compiler has been through this, what we call a front-end interface. And it's changed. I mean, certainly between the time that the code was closed source and the time that it got open sourced, it changed quite a bit. And it got whittled down to something much smaller. And in fact, this whole compiler environment class sort of built up from that. However, that work never really got completed. I would say it's still very much in a work in progress state. But what I'm saying is that perhaps the front end interface, if I can call it that, or the interface to the language environment from the perspective of the compiler, that should also be part of the API as well, because it's a means for the compiler to ask questions of the language environment using a consistent interface and expect to get some kind of an answer back. So defining what all those questions are and what the format of the answer and what the semantics of the answer are, I think is important to do as well. Opinions on that? Okay. All right. Okay. I'm just moving down my list here. So the other challenge that we're going to have is documenting the API, obviously, making sure that it's well understood. If the classes are going to be part of the API, then obviously we need to document those. Consistency would be a good goal to achieve as well. So having a consistent way of documenting all the classes, all the methods, all the data structures, things like that would be useful to do. I also think that, maybe if it was possible that there was some way that we could highlight what the public members actually were, the parts that are consumable. I think the way that Mark did it in JIT-Builder, I might have this backwards, but all the public methods start with a capital letter, whereas the internal ones are lowercase, something like that. So there may be a nice way of exposing that information, but documentation is going to be key. And finally, another thing to consider is the versioning aspects of it, and what are we going to allow to be changed across major and minor releases? Is there any way to either enforce or detect that there are incompatibilities with the API that a language environment is consuming versus what is provided in the current version of OMR that they're trying to consume? And can we detect that at build time and perhaps raise an error? So yet another aspect of something to possibly architect into an API. Okay. So I know we had a pretty good discussion at the early part of the call about what an API could possibly, the different aspects or the different kinds of aspects that that could make up an API. So I think there may be some ideas to distill from that discussion to help shape this, to help make this a more focused discussion going forward. So I mean, thanks for the opinions that were expressed and some of the ideas there. So perhaps one of the next steps here is to do that work and distill some of those ideas and to try to form something a little bit more concrete, and perhaps start moving this forward a bit. Are there any other opinions that people want to raise at this point? Okay, if not, by all means, please feel free to add whatever comments or thoughts you have to the issue that that I've created. I will say that this is not something that's going to happen overnight. It's going to take, I think, a fair bit of time and effort in order to evolve the code that we have. I mean, as Leo said, we're defining an API from an existing implementation, so it may not be easy to go from one state to the next. We may have to make sort of incremental, slower changes in order to evolve it to where we want it to be. But I think that the end goal is going to be important, especially for those that are already started on their projects that are consuming OMR, but also for newer projects that that haven't started yet, just to make it that much easier. So so I'll pull out some points from what was discussed today, and figure out the path forward here. So certainly invite everyone again to participate in further discussions that we have on this, because your input is very valuable here. Okay, if there's nothing else, then we can adjourn for today. So thanks everyone for your participation, and we'll talk again in 2 weeks. Okay.
Thanks very much,
everyone.
Thank you.
Thank you.
Bye.
Good.